Okay, so this is question number 7. We have been given a series of figures like this. Actually, sequence is the best word. Now we are asked to draw the fourth figure. Obviously, you have a wedge which is 1 in number. You have 2 wedges and then 3. The fourth one is going to be 1, 2, 3 and 4, right? So this is not difficult to guess and draw because it follows a pattern. Okay, but what is a little bit more challenging is the table. So there's a table given, so we will have to complete that table. So let me draw the table here. For the first figure, you have 1 plus 2 plus 2. Okay, so number of outer lines. This is the order they are giving. Perimeter is given as 5. For the second figure, you have 2 plus 2 plus 4. Perimeter is 8. For 3, it's 3 plus 2 plus 6. Perimeter is 11. Now moving on, we have figure number 6. We expected to get the exact distribution of the values, and we are also required to find the perimeter. Now foremost, you will have to identify the pattern. Now clearly you see figure 1 1, figure 2 2, figure 3 3. So definitely for figure 6 we are going to start with 6. Now next 2 2 2, so it's going to be 2 here too. Now over here you see here, this is 2, this is 4, this is 6. So 1 time 2 gives me 2, 2 times 2 gives me 4, 3 times 2 gives me 6. So there is a factor of 2 being multiplied to the first element, producing us the last element. So clearly 6 times 2 is going to give me 12. So clearly what I can see here is this constant pattern. The first element is actually proceeding from n is equal to 1, n is equal to 2, n is equal to 3. So I can rewrite it as n. The second element is always constant, so it's going to be 2, followed by the last element is a multiple of the first element. So this is going to be 2n. So this is going to be the pattern. If I were to sum it up, this is going to be 3n positive 2. So for whatever value of n we need, we can generate the distributions. So this is going to be coupled like this. Now what we need is, we need 21. So n is equal to 21. If I were to substitute n is equal to 21, so this is going to be 21 and the 2 is going to be featuring there, and 21 times 2 is going to be 42, right? So the perimeter is nothing but the sum of these elements. So in this case 2 added with 12 is 14, added with 6 is going to be 20. Over here this is 23 added with 42, that's going to give me 65. So that's it. So this is going to be the completion of this question. Okay, so with that, let us move on to the next part, and let me write the question down. Okay, so one more information is that we have given the middle row as n positive 2, positive 2n. So the 3n positive 2, this is going to be the perimeter, okay, for any n. So that would actually be the completion. Though we have written it here, it's better to distribute it in the table. Okay, now next is we are asked to find n if the perimeter is equal to 100. So we know perimeter is given, P is given as 3n positive 2, perimeter value is 100. We have to find the value of n. So this 100 minus 2 is equal to 3n. So 3n is equal to 98, and we need to get the value of n. So this means 98 divided by 3. Now this is not a whole number. Okay, 98 over 3 is not a whole number. So we need this value to be a whole number. So actually what the question is asking us is, it says that show that no figure can have a perimeter of 100. So clearly we have concluded here. So probably you can write the final conclusion. Conclusion is going to be, since n is equal to 98 over 3 is not an element of whole number, this means there can, probably I can write it like this, there can exist no figure. That's it. Okay, with p being equal to 100. Okay, just to add a buffer. So that is the conclusion. Probably you can box this and write it off.